I'm Joseph Abrams. I'm David Acevedo.
And I'm Tom Korsgaard. This is Lab 10. Fraunhofer diffraction, multiple slits.
Hi, in this experiment we're talking about multiple slits. Now with multiple slits we get a very interesting effect. What happens is the diffraction pattern, and here you can see it with 3 slits, starts to get these little smaller peaks that have interference in between the larger peaks. Now what happens is as we get more and more slits, those little peaks will become more numerous in between the large peaks, and eventually if we get a huge number of slits, like 1,000, those will actually level out, and what we'll have is we'll have even level, wider spaced peaks. This is caused because what's happening is we're getting multiple interference patterns where 3 or 4 waves or 5 or n number of waves are interfering, and so you're getting these very large packets of cancellation in between the wave peaks.
Here we have a laser, our slit selector, and our detector. The laser shines through the slits, which causes an interference pattern down here, which can be picked up by the detector. Using the slit selector, we can choose between multiple options for slits that change the size of the slit and the slit width. And down here, it creates a diffraction pattern that we can measure with our stepper motor.
The sensor is driven by a step motor. Now, the way this works is that first you push the button here, so that it's ready. Flip the switch so that it goes to the opposite direction, and then hit start. Now, you can't really see it, but the motor is driving it so that it moves slowly to the other side. And once we run our program, the sensor is going to pick up the diffraction pattern and then graph it on the computer.